Hello, everyone. This is Jaden, and I'm one of the lead programmers for Team 6962, the Pokebolts. And today I'm going to do a tutorial for a 4-servo, 3 degree of freedom arm, which we currently use on our robot to intake samples. And this tutorial isn't something that you're going to be able to just copy and paste into your file. We do a couple things differently, but it's good to see some principles and a technique that I've found for tuning this arm once it's assembled. So something I found out in the early season was that this file with 4 servos was just really messy when they were all inside the same arm tutorial class. And so I decided to break them up into separate classes. So a claw class, an arm class, and the wrist class, which will control 2 servos. And just some basic things. We'll initialize an op mode for later when we pass one into this class. And we'll initialize an instance of each claw. So and of course, I'm not an expert, and a couple of the things I'm doing probably aren't right, but this is a way I've found, and it works. I am pretty much completely self-taught. I didn't have any Java education last year, and I just threw myself in, looked at enough code, and just learned. So we've created an instance of our claw, an instance of our arm, and an instance of our wrist. Now we need a constructor for this entire arm. So something we do differently is that the constructor is essentially empty. You can put a couple things in there, but we actually put everything into an initialize function, public void initialize, and into this we will pass op mode. We call it op mode, and from this op mode there are a couple of things attached to it, which would be telemetry as well as a hardware map. And so this outmode.hardware map is where we can get different servos once we're ready. But instead, since we have this different organization, we'll actually pass this op mode into each of these classes one more time. Okay, I've pasted all these initialize functions, and they're actually going to be empty since we already passed this op mode into the class. And all of these subclasses will have access to it. And so usually we wouldn't do this in our code. We'd actually have a hardware map class that would go somewhere else, and that just allows for a bit more abstraction. But for the sake of this tutorial, we will simply get all the servos here. Get all the servos here in the class. Just skipping a bit of abstraction. And so this will be wrist for flipping the claw over. There will be a wrist for rotating the claw itself. And so this equals, we're just assigning device itself, right? And now those will all be initialized when you press init. And so now we'll get into the nitty gritty of it. I like to stick with constants for each of these classes. So we usually use a double. That will be, maybe your claw has an open position, and you will modify this later. And you'll have a closed position, and you can modify that later. I would put a to do there, but I don't think I need to. Right? And so now we will create a function within the biggest class, the ARM tutorial class. This will be something that I call operate. And this just runs in a loop during the op mode. So, and each time it will be past the op mode that it's running in. And so now you can do things like binding gamepad buttons to different functionality. And I'll leave this blank for now. Coming back to claw, here we're going to add another class, which I like to call incremental. And this is a tuning technique. It's probably not a valid technique, but I made it up and it works well. I made it up last year when I was a rookie programmer. And so what I like to do is I take the servo, I set its position to the servo's most recently set position plus an increment. That is another global-ish variable, or another constant that we can set here. I like to go pretty small, to the 1,000th, and this will actually be multiplied by an integer that we pass in. Right, so it reads its current position. This isn't actually its current position, it's the position it was told to go to last. So that's a bit of a flaw with this, but it hasn't been big enough of a problem. And then it adds an increment or subtracts depending on the value of sign. So we can go to maybe the left bumper, and usually the zero of a servo is the right, so we'll give it potentially a negative. And all of this, as long as they're opposites, it'll be okay. So this will be claw dot increment, and then we can bind it to another bumper. And so the purpose of this incremental that I've sort of invented is to act as if the servo was a continuous rotation. Because when the loop time is fast enough, this bumper will be read like a couple hundred times when you hold it for a second. And it will keep adding a tiny, tiny increment each time that loop runs. And it appears to be smooth movement. And we use this for tuning our claw. So after it's first assembled, you will initialize the op mode. You'll create an instance of ARM tutorial, and then this operate will go inside of that op mode. So I'll actually make one of those now. And this, our team prefers to use a basic iterative op mode. Before initialization, we need to create a new instance. So this can be private. I will call it until on equals new. Oh, we've capitalized these all wrong. Okay. And now we'll, in the initialize function, we'll call initialize, passing in this, which is this op mode itself. In start, we'll leave that empty for now. Intake arm dot operate. And so each loop, it'll pass in its current state, which also includes the states of each of the game pads. And so when you initialize this teleop, it will just continually loop, and you can use your left and right bumper to control the claw. And in addition to this, we need telemetry to give us feedback. And so when you initialize your op mode, you'll just start with a quick press to left bumper. If you hear the servo might be straining because of its set pose being out of range, you'll just touch the bumpers and hold them until they get to within range, so they're not trying to break your 3D printed or metal claw. And this just helps you get it right the first try, instead of having to use something like dashboard and just like type in a value, enter, and then try a different value, enter. And it helps you get it really precise down to the thousandth. And you do this with every single one, including arm and your 2 wrists. But we'll skip that for now, and we'll, instead of incremental now, we'll just go to predetermined set poses. So I'll create a public void command or method and call it open claw, simple name, and it'll just be servo.set position open position. Right, so after you've turned on the teleop once and you type in operate, and then you go through the operate, you use your left and right bumper, you move the servo to your open pause, and then you'll read off of telemetry, and then you'll paste that into here. Maybe it's 0.5, and then that will be saved once you push your code onto the robot via cable or ADB. So we'll do the same thing, close claw, pretty simple. And just the way that everything is organized now is pretty clean. You'll never have to type clawservo.set position in your teleop. This sort of forgoes rising edge detection at the moment. That's just not necessary when you're tuning. So if gamepad A, you'll just say claw or intake arm dot claw dot close claw. This dot claw is a bit of an extra step, and it is a bit tedious, but it just helps with organization. If I'm only trying to modify arm, I can command period, and these will just close. And then it's just easier to work on only the arm instead of scrolling until you can find wrists, which I've had issues with. So that's just about it. I will apply these to arm and wrist, and that's about it. This repository will be public on GitHub, and I will link it in the video description. And we have a lot more videos coming up, some CAD tutorials, as well as more basic Android Studio tutorials. Thanks for watching. Bye.